Hi guys, and welcome to yet another Genome2D Devcast. Today I'm going to talk about procedural dungeon generation. One of my focuses in my job for the last 2 weeks was approach to procedural dungeon generation. It's not just about random dungeon generation. Because even though I can generate dungeon randomly, and this is the picture of such dungeon generated purely by my algorithm without any input, but what I want to do is create parts of the dungeon procedurally, modify parts of the dungeon procedurally, and create tools for our game designers so they will be able to generate dungeons and content way faster than they do when they need to create all the parts themselves and think about designing the parts themselves. So this means that I don't not only can't do purely random stuff, because if you do purely random stuff, it's created based on some non-discrete elements, and you wouldn't be able to save it. So I need to create everything using seeds. I can't just random it based on time or something. I always need to create seeds. So when I create or generate a random dungeon, I need to be able to recreate it so it looks the same way when I save it and open it up. So, and as well, I need to be able to put things non-random into the dungeon that need to stay there. For example, I also created these energy tiles that you dig out in our game, and I can specify the amount of energy that should be inside this level, and it tries to keep the amount of energy on such value inside this level. So when I can specify the energy, the max energy needed to actually the total energy needed to dig out this dungeon. So I'm going to talk about my approach to room generation, my approach to path generation, my approach to the whole dungeon generation if you are interested in that. So let's start. We'll open my editor. This is a Genome2D editor. It's alpha at the moment, and it wasn't released yet. I will talk about it in the next Devcast, probably in between Christmas and New Year. I just happened to implement the tile and dungeon procedural generation inside the editor. So we will open the map. This is a sub editor for tile map generation. And we are going to create some rooms. Let's start with rooms. Firstly, good old rectangular rooms. They are very easy to implement and generate. You just basically generate random rectangle, yeah? So you can create these rooms. I will disable this at the moment. These rooms inside the level. Some dungeon generators I researched use only rectangles. Most of the dungeon generators used in Unity or Unreal or stuff like that use only rectangular rooms for some reason. They tend to generate a lot of rectangular rooms in the middle and then use the separation steering behavior so they move outside and they don't overlap, and then they just discard some of the rooms, or better yet, pick up some of the rooms which should be valid, and then they connect the rooms with straight lines, and then pick up some of the other rooms that were discarded on the lines, and voila, you have a dungeon. I don't really think. Firstly, it's not that great of a dungeon, I think, and secondly, it's always the same kind of look of a dungeon. So I don't really want just the rectangular rooms. So what I created next is a Perlin noise generator. I can show you. This is, for example, a room generated by a Perlin noise. When I tend to do randomization or procedural generation from my old days in a demo scene or my visual stuff I did for Genome and outside of Genome2D, I always grab Perlin noise. Perlin noise is a very good tool for not just for room generation. It's very specific for a lot of randomization can be, you can extract from Perlin noise a lot of useful info that can be used for various things. For example, here the room generation. What I do here is I generate a Perlin noise, then I pick up the random point in that noise map, and then I do a flute fill. So based on some kind of delta, I tend to fill all the neighboring tiles, and once we reach beyond the delta, it will just stop. So this is a flute fill algorithm generating a room on Perlin noise. I can show you because I can just modify the delta, and when I modify it to a really low value, and now I run the Perlin noise generator, you see it tends to generate larger rooms. So I can go even lower. You can play with it. You can even generate multiple rooms on that same noise. And build yourself some kind of caves without a problem. So Perlin noise is a really nice solution for a room generation, or I would say cave kind of generation. Next I implemented is a cellular generator. I think a lot of you are aware of the game of life, which is based on the cellular automata, which is basically you have a few, I generate few walls into the grid, and then based on this cellular automaton, the next generation will switch these walls to either room, or they will stay walls, or they will vanish. Basically, walls and vanishing is the same thing in my, because empty space is basically wall, or will generate a wall. So let me show you. This is what happens when I run the cellular automata with a few walls put randomly into the tile map. It tends to generate really nice dungeon. But what I saw is that it tends to generate quite narrow paths. For example, in our game, we just go horizontally or vertically. We can't go diagonally. So, for example, if there was a wall here, you wouldn't be able to pass. So, what I did as a post process for the cellular automata is that I expanded the room. Expand something like this. You can do that as well. And what it does is just evaluates each tile on the map and checks its neighbors. And if there is a lot of rooms, basically, it will switch it from a wall to room, so it will expand the corridors. So one room tile will become two, stuff like that. You just watch out if you do this, that don't modify it under you. You always need to clone the array and modify the array, basically. Even for cellular automata, which we are doing that, you can't modify the array because the generation would, the cellular automated generation would basically be based on already modified data. You know, if you modify a tile at x and epsilon, the x plus 1 and epsilon uh, would evaluate the previous tile that was already modified in this generation, and this applies to the expand and shrink. Shrink. Shrink is basically the reverse of expand. This is how expand and shrink looks on a rectangular room. So if you want to see how this starts, I can just put it to a zero generation cellular. Oh, this is the Perlin one. As you can see, I just generate these walls here. Yes, it's that simple. And then I switch the walls to to another wall or to a room based on these cutoffs. So cutoffs. This is the first radius cutoff, and this is the second radius cutoff. It will evaluate the type of tile types in that radius. So if there are 5 walls near the wall, it will switch to room and stuff like that. So and we can obviously create a load of generations. It will change based on that. The wall probability is at 45%. That's the amount of walls generated in the zero generation. With the first step, there is nothing there, so we need to randomize it. So we put it there based on some kind of value. And the final generator is a diffusion generator. It's using diffusion limited aggregation, which is basically natural phenomenon for particles undergoing Brownian motion, if you want the Wikipedia article. So what Brownian motion is, it's how particles behave when they are diffused in some kind of liquid. It's basically, we can, to simplify things for us, we can tell that that's how particles behave in some kind of space or something. So we will generate the dungeon based on particles. This is how it looks. Let me show you. So what we do here, I can even expand it a lot. What we do here is, okay, let's reset it. If I set the number of traveling particles to 0, we will see the initial step actually. We create a few particles and disperse them in the middle of the dungeon. They will create the room for us. And then we are dispersing the traveling particles. Traveling particles are basically particles that you disperse in the level, doesn't matter where. I am using the outside radius here, so I'm dispersing in this space. And they have some kind of movement algorithm. You can pretty much do any movement. My movement is that they tend to converge to the middle. Always try this. Let me show you. So for example, if I disperse the particle here, it will try to converge here. And once it hits already defined room space, it will stop, and then it will generate the path along the way it traveled. If I used the motion that it wasn't converging to middle, it tended to take a lot of time for even for small number of particles. What I can do, and I will do probably to generate, for example, cycles and stuff like that, I will tell the particle to move randomly for a limited number of steps, and then it should start converging to middle. Or I can base it on some kind of delta when it should start converging to middle. So it tends to generate these kind of snowflakes, and they are always connected. There is obviously exception when the base is not connected. If you have the base covered a lot, so it's connected, then the whole graph will be obviously connected because the particles travel and generate a path. When we can do the expand post-process on it as well to generate a little bit of more wider spaces. This algorithm is really nice, and what we can do even, for example, if we wanted this kind of dungeon from the start, from this algorithm without the expand post-process, we can tell the algorithm that the particle is 2 by 2, not 1 by 1, not 1 tile but 4 tiles, and then it can generate these wider dungeons. You can even have different type of particles. There are no limits to that, so it can generate pretty crazy stuff if you want. So you can play with it. We can even combine these algorithms. For example, we can generate the middle using Perlin or Cellular automata, and then run the particles into it. Particles this kind of algorithm can be even used to generate, for example, generate paths if you run it on something like this. I didn't implement that, but it's possible. Why not? So those are the 4 generators I'm using to generate room. Next, I am going to generate paths. What I'm using to generate path is, let's disable the UI, is or was A star. But I moved to Dijkstra, and I'll tell you why. As you know, that A star is just a specialized algorithm based on Dijkstra, and A star is basically using heuristics to help itself. So in this case, for a tile-based 2D dungeon, the heuristic is very simple, and we are only using the horizontal and vertical motion. So, but I don't really need the heuristics because I don't really need the smallest possible path. Yeah, I want a randomized path. This is how the smallest possible path looks actually. But what we can do, because this is not really much we can work with, you can work with this, and some type of dungeons actually want this type of corridors, but most of the dungeons don't really want to look like this. So what I'm using here is again good old friend Perlin noise. So if I enable the Perlin cost for the pathfinding and run it again, this is how the dungeon looks. Because the heuristic based cost is no longer actually it is the the lowest cost, but it's a lowest cost based on the Perlin noise values. So it's not a constant distribution of values. Some people used just purely randomized grid for the cost of A star and or Dijkstra. Don't do that. I tell you why. Because if you distribute the costs with the basic random generator, it will distribute the values pretty much linearly, and you will tend to get almost the same paths like this. Because if the cost is distributed linearly, it will also generate something if there was a linearly constant value of the cost, if you know what I mean. So either use a random generator that's not a linear distribution, or use something like Perlin cost with a specific values, so you can get something nice like this. And as you see, if I just enable it, disable it, it always generates the same dungeon because it's seeded. And since the cost is seeded, the Dijkstra algorithm will find the same route, so you can easily save that. Another thing I can do, let's put a few rooms here. Let's say I want to connect these two. It's basically found a way through this room, which is the closest way. But what if I don't want it to go to this room? I can specify on my route that I don't want the worker to be able to go through rooms. So we will go around the room. And this is based on just of the partial path, because if I can create a non-partial, I can multiple points path, obviously, and this part can go through room, this part can't go through room if I want it. I can specify that this part of path should we not use the Perlin cost, so you can have this part with a nice lowest cost possible. Anyway, this is even cool for if I want to go, let's clear it. Let's say I have these two rooms, and I want to go from here to here, or from here to here. So it will go through this room and go here. I will just put it here. But what if I want to go here, from here somewhere and then here? I will just specify that it should not go through rooms, and it will try to go around. But now if I go here, there is no route because it can't walk through rooms, so you need to put a door there. Door is if you put it in the wall. So I just generate some caves. I can move rooms and it will always detect the doors or the points it contains and move them as well. So if the designers want to modify the dungeon, it's very easier for them. If you create a room, if you create a pad here and then create a room, you will try to, oh, this is walkable through room, but if I tell it to not be able to walk through room, a part of it is, because it always takes the second point, so this point is walkable, so this part is walkable through rooms, this part is not walkable through rooms. If I specify this is not walkable as well, it will try to go around as well. And you can generate these types of dungeons. As you can see, if I move it, and all these diggable tiles regenerate. Because now, when I change it, everything tries to invalidate everything, all the pathfinding, all the Dijkstra, stuff like that, except the room generation. And I will obviously change it so it only detects the changes that were actually changed and invalidate them, so it no longer generates, but just generate the parts that were changed, like this path from point 1 to point 2. If we are going to implement this algorithm, just watch out for the performance, because let me tell you, Dijkstra on 100 by 100 grid and on multiple, because this is multiple pathfindings, can actually get pretty heavy, so watch out. I did a little optimizations for that. We can also create negative space. So let me create, let's say I want this room to be negative, and it can create negative space. No problem, I can even obviously create negative space from, I want to see them, negative space from other generated rooms. If you combine all this, you can pretty much generate anything. I'm just using the limited amount of assets because I could create different rooms with different graphical assets, but it's not the point of this presentation. So I'm just using the limited amount of assets. Now, if you want to, I can show you how I actually generate purely random dungeons. I don't have the algorithm running here, but what I'm using is Delaunay triangulation. We can actually enable it. And the Delaunay triangulation of the average centers of each room generates this nice graph, unidirectional graph. And we can also generate from it the minimum spanning tree, because what minimum spanning tree is that it actually connects all the vertices. It doesn't create cycles, and it creates the road with a minimum edge length. So it's the minimum path one can actually travel between these points. And now I can tell the program to actually generate paths based on this minimum spanning tree. I can actually tell it to use the whole Delaunay triangulation to generate paths. You can even use just minimal spanning tree to be sure that all the rooms are connected, and then you can just randomly pick some of the other edges and connect those to have a little bit more paths if you want. Or you can just delete some of the paths if you don't really want rooms connected. Okay, show me this, because I don't really need this connected. Okay, this is the point here. Because in our game, not all rooms can be or will be connected, because we have multiple floors, and this room can be accessed from another floor, not really from this floor. You can actually use the relative neighborhood graph as well, instead of minimum spanning tree. It's usable and outputs great results. I can implement it, but I'm not really focused on this whole dungeon random generation. I want just part of the stuff to be generated randomly. And I can actually save this and load this, and it will look the same as it does now. Some of these algorithms will find its way to the core codebase of Genome2D, like the A-star, for example, because A-star is really usable in a lot of scenarios. And even though it's part of a lot of libraries, it's not really that complicated to that large, so it will not inflate the codebase as much. I'm not going to put the Delaunay obviously into the Genome2D codebase, because there are a lot of Delaunay libraries or triangulation libraries as well. I may put ear clipping. Ear clipping triangulation is not used in this. It doesn't really works for this kind of scenario, because it's simple and will not inflate the code base. But if you want to use the Delaunay, there are a lot of libraries for Delaunay as well. And once you have Delaunay, you can generate the minimum spanning tree. So guys, this is pretty much all. That's what I was working on currently. If you have any questions, and if you need to, for example, you need some help with randomization or dungeon generation, or you have some ideas, I'm all ears, how to generate random dungeons. It can be even used for 3D dungeons. It doesn't matter. I can implement this in Unreal Engine and create 3D worlds for this. I can even randomize the floors, so some of them will be higher, some of them lower, and stuff like that. It's not really a problem. What I'm going to implement next is I'm going to implement the per room. I already have them, but they don't execute anything. It's a per room script. So each room, so if I clear this, each of these rooms will have a script that evaluates the value it runs into it once it feeds what actually consists from these rooms. So you can create, for example, a checker floor based on X and Y value inside the room, or you can always generate some kind of a pillar in the corners or stuff like that. It's really fancy stuff, and it can even tell that these only should contain a snow tile or something like that. It's not really complicated. It's just very simple scripts. No more math. The math part and the graph theory part is already covered. So next Devcast will be probably, as I said, between Christmas and the New Year, and I'm going to talk about the editor basically. So looking forward to that. Looking forward to any feedback, and thank you guys.